Python modules Part 4, SYS module. The SYS module in Python provides functions and variables used to manipulate different parts of the Python runtime environment. Here are some of the most commonly used functions and variables in the SYS module. Functions. 1. SYS.exit exits the program with a specified status code. 2. SYS.version returns the version of the Python interpreter. 3. SYS.platform returns the platform name, example Win32, Linux, Darwin. 4. SYS. ARGV returns a list of command line arguments. 5. SYS.path returns a list of directories where Python searches for modules. 6. SYS.modules returns a dictionary of loaded modules. 7. SYS. Stout, SYS. Str, SYS.stin, file objects for standard output, error, and input. Variables. 1. SYS. Max size the largest possible integer in Python. 2. SYS.float_info, information about the floating point type. Example usage. Import SYS. Print, SYS.version, #prints Python version. Print, SYS.platform, #prints platform name. Print, SYS.argv, #prints command line arguments. SYS.exit, 0, #exits the program with status code 0. The SYS module provides a way to interact with the Python interpreter and access various system-specific parameters and functions. Introduction. The SYS module in Python is a critical component that provides access to system-specific parameters and functions. It allows you to interact with the Python interpreter and runtime environment effectively. This module is essential for developing robust and flexible Python applications. Key features and uses, 10 points. Accessing command line arguments, SYS.argv. Manipulating paths, SYS.path, SYS.platform, SYS.executable. Interacting with the interpreter, SYS.exit, SYS.stout, SYS.str, SYS.stin. Getting information about the Python environment, SYS.version, SYS.maxize, SYS.byteorder. Other useful functions, SYS.modules, SYS.getRefCount, SYS.strecursion limit. Common use cases, 10 points. Command line argument parsing. Script portability across different platforms. Error handling and logging. Module and package management. Performance optimization. Debugging and introspection. Platform-specific behavior. Interacting with external processes. Customizing the interpreter's behavior. Accessing environment variables. Detailed explanation and examples, 30 points. Accessing command line arguments. SYS.argv, a list containing command line arguments passed to the script. Import SYS. Print, script name, SYS.argv0. For arg in SYS.argv1. Print, argument, arg. Manipulating paths. SYS.path, a list of strings representing the search path for modules. Import SYS. Print, current working directory, SYS.path0. SYS.path.append, /path/to/my/modules. SYS.platform, the platform the code is running on, example Win32, Linux, Darwin. Import SYS. if sys.platform equals Win32. Hashtag Windows specific code. If sys.platform equals Linux. Hashtag Linux specific code. Sys.executable, the path to the Python executable. Import sys. Print, Python executable, sys.executable. Interacting with the interpreter. Sys.exit, terminates the program. Import sys. If error_condition. Sys.exit, error occurred. Sys.stout, sys.str, standard output and error streams. Import sys. Print, this is standard output, file equals sys.stout. Print, this is standard error, file equals sys.str. Sys.stin, standard input stream. Import sys. User_input equals sys.stin.readline. Getting information about the Python environment. Sys.version, Python version information. Import sys. Print, Python version, sys.version. Sys.maxsize, maximum value a Python integer can hold. Import sys. Print, maximum integer, sys.maxsize. Sys.byte order, the byte order of the system, little or big. Import sys. Print, byte order, sys.byte order. Other useful functions. Sys.modules, a dictionary of loaded modules. Import sys. For module_name in sys.modules. Print, module_name. Sys.getRefCount, object returns the reference count of an object. Python. Import sys. X equals 10. Print, sys.getRefCount, x. Sys.stRecursion limit sets the maximum depth of recursion. Import sys. Sys.stRecursion limit, 1000. Additional tips and best practices, 10 points. Use sys.path carefully to avoid unexpected module imports. Consider using argparse or optparse modules for complex command line argument parsing. Handle potential exceptions when using sys module functions. Explore other functions and attributes in the sys module based on your specific needs. Document your use of the sys module for better code readability. By understanding and effectively utilizing the sys module, you can write more sophisticated and adaptable Python programs. Here are 20 additional points about the sys module in Python. 1. Sys.displayHook, a callable that displays the result of an expression evaluated in the interpreter. 2. Sys.acceptHook, a callable that handles uncaught exceptions. 3. Sys.getDefaultEncoding, returns the default encoding used for strings. 4. Sys.getFileSystemEncoding, returns the encoding used for file system operations. 5. Sys.getRecursion limit, returns the maximum recursion depth. 6. Sys.getRefCount, returns the reference count of an object. 7. Sys.getSizeOf, returns the size of an object in bytes. 8. Sys_getFrame, returns the current frame object. 9. Sys.hash_info, information about the hash table implementation. 10. Sys.int_info, information about the int type. 11. Sys.last_traceback, sys.last_type, sys.last_value, information about the last exception. 12. Sys.maxUnicode, the maximum Unicode code point. 13 sys.meta_path, a list of metapath finders for importing modules. 14 sys.modules.keys, returns a list of all loaded module names. 15 sys.path_hooks, a list of callable path hooks for importing modules. 16 sys.path_importer_cache, a cache of path importers. 17 sys.platform, the platform name, example Win32, Linux, Darwin. 18 sys.prefix, sys.exec_prefix, the installation prefix and executable prefix. 19 sys.strecursion limit, sets the maximum recursion depth. 20 sys.setRace, sets the trace function for debugging. These points cover various aspects of the SYS module, including exception handling, encoding, file system operations, debugging, and more. 5. RE module in Python. The RE module in Python provides support for regular expressions, regex. Here are some key functions and features. Functions. 1. Research, pattern, string searches for the first occurrence of the pattern in the string. 2. Rematch, pattern, string searches for a match at the beginning of the string. 3. Refindall, pattern, string finds all occurrences of the pattern in the string. 4. RefindIter, pattern, string finds all occurrences of the pattern in the string, returning an iterator. 5. Resub, pattern, replace, string replaces occurrences of the pattern with the replacement string. 6. Resplit, pattern, string splits the string into substrings separated by the pattern. Patterns. 1. Matches any character. 2. Matches the start of the string. 3. Matches the end of the string. 4. Matches 0 or more occurrences. 5. Matches 1 or more occurrences. 6. Matches 0 or 1 occurrence. 7. Matches exactly n occurrences. 8. ABC, matches any character in the set. 9. Matches either the expression before or after. Modifiers. 1. Re-ignore case, ignores case. 2. Re-multiline, makes caret and $match line boundaries. 3. Re-total, makes match new line characters. Example usage. Import re. Text equals hello, world. Match equals research, our world, text. If match. Print, found, match.group. Replacements equals resub, our world, our Python, text. Print, replacements, #output, hello, Python. This example demonstrates basic usage of the RE module, including searching and replacing text using regular expressions. Python's RE module, a powerful tool for text processing. Understanding regular expressions. Before diving into the RE module, it's essential to grasp the concept of regular expressions, regex. These are sequences of characters that define a search pattern. They are incredibly versatile for tasks like data validation, checking if input data conforms to specific formats, example email, phone numbers. Text extraction, pulling out specific information from text, example URLs, dates. Text replacement, modifying text based on patterns, example removing unwanted characters. Search and replace, finding and replacing text within a larger body of text. Importing the RE module. To use regular expressions in Python, you'll need to import the RE module. Import RE. Core functions in the RE module. Rematch, matches a pattern at the beginning of a string. Research, searches for the first occurrence of a pattern within a string. Refindall returns a list of all non-overlapping matches in a string. Resub replaces occurrences of a pattern with a specified string. Recompile compiles a regular expression pattern for efficiency. Example, extracting email addresses. Import re. Text equals my email is example@example.com, and yours is another at example.net. Emails equals refindall, r\s plus @s plus, text. Print, emails, #output, example@example.com, another at example.net. Common regular expression patterns. \d matches any digit. \w matches any alphanumeric character. \s matches any Whitney space character. Matches any character except new line. Asterisk matches 0 or more repetitions of the preceding character. Plus matches 1 or more repetitions of the preceding character. Matches 0 or 1 occurrence of the preceding character. Caret matches the beginning of a string. Dollar matches the end of a string. Compiling regular expressions for performance. For repeated use of a regular expression, compiling it can improve performance. Python. Import re. Email_regex equals recompile, r\s plus @s plus. Text equals multiple emails here, user 1 at example.com, user 2 at example.net. Emails equals email_regex.findall, text. Print, emails. Additional tips. Use online regex testers to experiment with patterns before implementing them in your code. Break down complex patterns into smaller, more manageable components. Consider using raw strings, r-pattern, to avoid escaping backslashes. Be mindful of potential edge cases and test your regexes thoroughly. Practical use cases. Data cleaning, removing unwanted characters, standardizing formats. Web scraping, extracting information from HTML or other text-based formats. Log analysis, parsing log files to extract relevant data. Text processing, analyzing and manipulating text data. Form validation, ensuring user input matches expected patterns. Statistics module. The statistics module in Python provides functions for calculating mathematical statistics of numeric data. Here are some key functions. 1. Mean, data returns the mean, average, of the data. 2. Median, data returns the median, middle value, of the data. 3. Mode, data returns the most common data point, mode. 4. Stdef, data returns the standard deviation of the data. 5. Variance, data returns the variance of the data. 6. Stdef, data returns the population standard deviation of the data. 7. Variance, data returns the population variance of the data. 8. Median_low, data returns the low median of the data. 9. Median_high, data returns the high median of the data. 10. Quantiles, data returns the 5-number summary, min, Q1, median, Q3, max. Example usage. Import statistics. Data equals 1, 2, 3, 4, 5. Mean_value equals statistics.mean, data. Print, mean _value, #output, 3. Median_value equals statistics.median, data. Print, median _value, #output, 3. Mode_value equals statistics.mode, data. Print, mode _value, #output, 1, assuming no duplicates. std_dev equals statistics.stdef, data. Print, standard deviation, std_dev. This example demonstrates basic usage of the statistics module, including calculating mean, median, mode, and standard deviation. Python's built-in statistics module provides essential functions for calculating mathematical statistics of numeric data. It's a valuable tool for data scientists, analysts, and anyone working with numerical data. Key functions and usage. Basic statistics. Mean, data calculates the arithmetic mean of data. Median, data computes the median, middle value, of data. Mode, data returns the most common data point. Harmonic_mean, data calculates the harmonic mean of data. Median_low, data returns the lower of the two middle values for odd-length data. Median_high, data returns the higher of the two middle values for odd-length data. Median_grouped, data, interval calculates the median of grouped data. Measures of dispersion. Variance, data, mu equals none calculates the population variance of data. STDEF, data, mu equals none calculates the population standard deviation of data. Variance, data, SPAR equals none calculates the sample variance of data. STDEF, data, SPAR equals none calculates the sample standard deviation of data. Other functions. Quantiles, data, asterisk, n equals 4, method equals inclusive computes quantiles of data. Covariance, x, y calculates the covariance of two data sets. Correlation, x, y calculates the Pearson correlation coefficient. Example. Import statistics. Data equals 2, 4, 4, 4, 5, 5, 7, 9. Print, mean, statistics.mean, data. Print, median, statistics.median, data. Print, mode, statistics.mode, data. Print, variance, statistics.variance, data. Print, standard deviation, statistics.stdef, data. When to use the statistics module. Basic statistical calculations, when you need to quickly calculate mean, median, mode, variance, and standard deviation. Data exploration, to understand the distribution of your data. Data pre-processing, as a preliminary step before applying more complex statistical models. Limitations of the statistics module. Primarily focused on basic statistics. Limited support for complex statistical distributions and tests. May not be suitable for large datasets or computationally intensive tasks. Alternatives for advanced statistics. For more advanced statistical analysis, consider using libraries like NumPy, provides efficient array operations and linear algebra functions. SciPy, offers a wide range of scientific computing functions, including statistical distributions and hypothesis testing. StatsModels, built on NumPy and SciPy, provides statistical modeling, testing, and exploration tools. Pandas, offers data structures and analysis tools for working with structured data. Conclusion. The statistics module is a valuable asset for Python developers dealing with numerical data. While it provides essential functions for basic statistical calculations, it's essential to consider using more specialized libraries for advanced statistical analysis. The tkinter module in Python is a standard GUI, graphical user interface, library that provides an easy-to-use interface for creating desktop applications. Here are some key features and functions. 1. Widgets. Tkinter provides various widgets such as buttons, labels, text entries, and menus to create GUI components. 2 Windows. Tkinter allows you to create and manage windows, including setting titles, sizes, and positions. 3 Layout Management. Tkinter provides layout managers like Pack, Grid, and Place to arrange widgets in a window. 4 Events. Tkinter supports event-driven programming, allowing you to respond to user interactions like button clicks and key presses. 5 Canvas. Tkinter's Canvas widget allows you to create custom graphics and animations. Some common Tkinter functions include: 1 TK creates a new Tkinter window. 2 Label creates a text label widget. 3 Button creates a button widget. 4 Entry creates a text entry widget. 5 Pack, Grid, Place, layout management functions. 6 Main Loop starts the Tkinter event loop. Example usage: import Tkinter as TK. Root equals link unavailable. Label equals TK label, root, text equals hello, world. Label.pack. Button equals TK button, root, text equals click me, command equals lambda, print, button clicked. Button.pack. Root.main loop. This example creates a simple window with a label and a button that prints a message when clicked. Introduction. Tkinter is Python's standard GUI toolkit. It's relatively easy to learn and use, making it a popular choice for creating simple to moderate GUI applications. While it might not be as feature-rich as some third-party options, it's a great starting point and sufficient for many projects. Basic structure of a Tkinter application. A typical Tkinter application involves these steps. Import the Tkinter module. Import Tkinter as TK. Create the main application window. Root equals TK. Create widgets. Tkinter offers various widgets like buttons, labels, entry fields, text boxes, etc. Python. Label equals TK label, root, text equals hello, world. Button equals TK button, root, text equals click me. Place widgets on the window. Use geometry managers like Pack, Grid, or Place to arrange widgets. Python. Label.pack. Button.pack. Start the event loop. This keeps the application running and responsive. Root.main loop. Example, a simple calculator. Import Tkinter as TK. Def calculate. Try. Result equals eval, entry.get. Label underscore result.config, text equals str, result. Accept. Label underscore result.config, text equals error. Root equals tk. Root.title, simple calculator. Entry equals tk entry, root, width equals 20. Entry.pack. Button equals TK button, root, text equals calculate, command equals calculate. Button.pack. Label underscore result equals TK label, root. Label underscore result.pack. Root.main loop. Key widgets and their uses. Label, displays text or images. Button, triggers actions when clicked. Entry, allows user input. Text, displays multi-line text. Frame, container for grouping widgets. Menu, creates menus and submenus. Message, displays multi-line text with word wrapping. Event handling. Tkinter supports event handling, allowing you to respond to user interactions. Button.config, command equals lambda, print, button clicked. Geometry managers. Pack, simplest layout manager, packs widgets into rows or columns. Grid, aligns widgets in a grid-like structure. Place, provides precise control over widget placement. Additional tips. Use clear and descriptive variable names. Organize your code into functions for better readability. Consider using object-oriented programming for complex applications. Test your application thoroughly on different platforms. Going further. While Tkinter is a good starting point, for more complex GUI applications, you might explore PyQt, offers more features and customization options. WXPython, another popular cross-platform GUI toolkit. Tkinter's TTK module, provides themed widgets for a modern look.